And then we have Nandish with HP Enterprise.
All right, so I'm Nandish, and I work at Hewlett-Packard Enterprise here at Fort Collins, Colorado. And yeah, so we have developed a suite of tools using the OpenAccess, and the main focus for us is to have, to reduce the designer time and fetch the design information using command line tools specifically. And the second goal is to reduce the time for development of such tools, which we'll see on how using Python bindings will help us. So, so let's see some of the tools we have developed here at HPE. One of the tools is hierarchy traversal tools. So it's a common use case we found here is the designers often want to view the hierarchy and go up and down starting from a given cell. So we developed a command line tool to do this, and it actually improves the readability significantly, because if you open up the design in the design editor, you'll have to open up them in the tabs or in different windows, as opposed to like seeing all of them in a single view. So we specifically focus on getting the instance names, cell references, and things like that, and extending this concept. We also have written scripts to use GraphViz software and visually represent the hierarchy, which we have found to be very useful. Okay, so the other tools we have, building on the hierarchy traversal tool, we developed a dependency checker tool. And this dependency checking tool tells us whether a top-level cell analysis is up to date with respect to its child cell design hierarchy. We do this by capturing, an identity stamp of the cell's analysis or result files, and all of the dependent child cell files at the time of analysis. For example, you run. Say you want to run timing at a given cell, and you want to make sure all the predecessor files that feeds into timing, like and Verilog and all the other files are all up to date. And on top of that, we also want to make sure the design is up to date. So this dependency checking is, we achieve this by using basic identity information of the design files, such as file size, modification time, MD5, sum of the file, etc. And this has proved to be very useful to get a quick look at if the design flow needs to be rerun or if we are good with the current results we have. So the next tool we developed is when we started facing problems with the broken links in a big libdefs file, and it was pretty hard to find. So we developed a tool which checks for the broken directory links in a log in a given libdefs file. It's very useful when you're setting up new work areas, when you're copying design from work areas to a local disk, or you're changing symlinks on disks when you have moved a design to another disk. And another useful tool we have is to find the directory of the cells in the OpenAccess tree, and this helps us to change directories quickly to those cells, and it's found to be useful for us. And on a similar note, we also have tools to query the design information, such as what ports we have on the design, what nets we have, and how they're connected. And these things, we can use this information to develop more programs that can give us useful information. Like, for example, we have a tool that traces the signals all the way to the leaf cell if you start at a pretty high up hierarchy. So the basic advantages of this, as I mentioned earlier, is to avoid opening a design editor to get such information and to have all this information available on the command line. And the other useful thing is you can incorporate such results in your programs like Python, Perl, or whatever you're interested in. So talking about Python bindings, we saw earlier in a couple of presentations, they're using Python bindings for OpenAccess. And I want to touch on why we should encourage our teams to go for this. One of the main things is, we have come across designers who have great ideas to do things with the design, but are reluctant to spend time and effort writing C++ code and deal with the pointers, memory management, and all those stuff. This is where Python bindings come to help us. You might think, is it a different kind of APIs that are exposed? Well, the answer is no, because the access to OpenAccess data is only through C++ API. The Python interface to these C++ APIs is handled using Swig. So you're essentially utilizing the same APIs, but using a higher level language like Python. You can also use Perl, Tcl, and Ruby as well. But we stuck with Python. So if you're interested, you should definitely check out the README files in the oaScript, and they're really helpful. Yeah, the main advantages of using Python for developing applications is rapid prototyping compared to C++. The hierarchy traversal tool I mentioned earlier, we were able to prototype a version of it in just like 15 minutes. So it's pretty amazing compared to the time taken with C++ to develop such tools, because you always are dealing with pointers, references, and memory management. And Python takes care of memory management, so you're off the hooks for that. Another interesting point I found was it enables tab completion of attribute names when you have set up your IDE properly, your Python IDE, and this avoids having to visit the OpenAccess documentation every single time you want to query some attribute name on a given object. So we found that one very useful. Also, Python has so many unit testing frameworks, and we have taken advantage of PyTest, which is a great framework for testing Python code, and it has given us great confidence in our code. So, please do write unit tests for all your Python codes, and even though the time taken will be a little bit longer, it will definitely help us in the long run. And the other thing I want to say is use the optimized share library files instead of the debuggable ones when using Python OpenAccess bindings.
Yes, this is Vijay from Intel. I have a question.
Yep.
On slide number 3, where you had the tool for tracing the signal down to the C cells, is the output also include a way to load it into your design canvas to look at it?
No, this is just command line output.
All right. Okay.
I mean, so, you could write such a tool.
Right. You also had some visualization utility earlier. Does it tie together?
No, we have not tied them together.
Okay. Thank you.
Other questions?
Yeah, Tom here at Mythic. So I suggested years ago to someone doing an OA presentation that in the kind of the command line tools that were available, a read line would be very useful. And it seems to me that the IPython approach gives you the benefits of, as you said, tab completion. So I guess maybe you could comment on that a little.
So are you asking how I set it up, or sorry, I did not completely get
so, So with, I guess you're either relying on the abilities, the facilities that IPython gives you kind of natively, or you can kind of instrument the interactive mode to give you a smarter kind of tab completion and so forth. And I wonder if you've considered that option, or you're just using kind of out of the box.
We are currently using just the Python IDE, not exactly the IDE, sorry, the Python shell, the interpreter of the Python that comes with the installation of Python itself, and yeah, we can definitely set it up with IPython or even with other IDEs.
Okay, thanks. I think it'd be very valuable. Thank you.
Yes, we also, in your SharePoint directory, we have a presentation archive from previous forums, and one of the presentations, Corey Krug, was one with Python Jupyter, which also supports the command completion. You might check that as an interesting presentation. Another thing to note is in that same area of SharePoint, there is a code repository. So if there's any, doesn't have to be complete executable code, even a function or a snippet or even a screen grab as part of a program that illustrates a more efficient way of doing something that anybody would like to share, that can go into that code repository. So see me if you have anything interesting that you'd like to share with the rest of the developers.
Marshall, are the presentations from today going to be on the SharePoint?
Yes, they will. We're going to need a little bit of time because we're going to offer them also in video form, and so we'll be putting up the presentations and the videos. Though the presenters will have right of final rejection for my editing. So as soon as I get approval from all of the presenters, yes, they will be up there.
Any more questions for me?
Thalam at Mythic again. I was just going to comment on what Marshall said. Thank you, Marshall. The Jupyter kernel is like the next generation of IPython, so obviously be a great place to start.
Yeah, a quick question. When you mentioned Python bindings, I'm presuming is this the oaScript, the latest oaScript or bindings, or the older Python bindings that were created several years prior?
We are using the oaScript. Yeah, I was referring to the oaScript itself. So we are currently using version 3.3 of oaScript. We are yet to try the new ones.
Okay, thank you.